Okay, we're live. Yeah, okay. So, finally live. Took a second because the Seahawks game was a very good game, and we won. So, I'm very happy about that. Anyways, hello world. This is day 147 of studying compilers every day until I land a compiler role. Last time we slow ran a lot of code stuff. It was supposed to be a bit of a speed run, and then it went long. But yeah, that's kind of just a common theme with my stuff now, I fear. This time we're gonna do some like small stuff here and there. Mostly getting like the test runner cleaned up a little bit because it's very boilerplate, and that makes me very upset. And then probably trying to implement at least a little bit of the regalloc functionality. My plan is probably like at least just like a helper function for spill, which just like goes through everything and generates spill code around certain instructions that use a specific register. What's good, Useless? Good to see you. I'm doing well. Hopefully you're doing all right as well. Yeah. So if we look through this, yeah, we kind of just threw this at this and called it a day. We kind of just blew up regalloc a little bit more. So if we look in the regalloc file, all of the helpers are gone, and all of a sudden passes is a directory instead of analyses. And now we have like coalesce, which has all of our like coalesce stuff. We have coloring, which has all of our coloring stuff. I guess these are the correct types. And then the last one we have is spill, which has, I guess, all of our spilling related things, I guess. We also probably want one more. We probably want one more helper of some sort. I'm not really sure where that is, but we'd probably be editing spill here. Yeah, I'm not really sure how to determine what register is like the buffer register, but it'll be interesting. Yeah, so I guess first let's do the test thing, because when I was looking through that last time while making changes, it was really bothering me. So as you can see here, there's so much slush garbage boilerplate. Yeah, so I'm trying to figure out how to make this less awful. I guess how do we discover tests, I guess? We have like the source file, and then where does it skip? So I guess let's make real quick. And we can look at the output, and that might help a little bit. Okay, so this slush, let's actually just let's just run this instead. Okay, so we literally have a skip somewhere. I'm not really sure where skip lives, or I guess where the skip is coming from. Okay, I guess we know where the skip is coming from. So then I guess this is a little bit slow because we're running everything even if there's no compare. So maybe we like run this sooner? There's like only a couple that use like very specific output formats. So I think we could probably do better with this. Either that or we could filter by output actually. We could look at like output dir. I guess what's it called? Expected, I guess. Yeah, that might be smarter. Let's do this sort of renaming thing. So we can do that. Let's replace input with expected. Oh, this is really annoying, actually. Okay, we might just have to like do a lot of new lines. So we have C, or I guess we have AST, HIR. Actually, we could probably just... We could probably just use all of these, right? Because each of these is like one quote-unquote test, I guess. So we could probably do this. Yeah, we could do that, I think. And then we sort it. Sure, fair enough. Okay, and then we just have a list of strings here. Oh, we have a... Wait. Oh, no, this wouldn't work. G-test moment. Okay. We might just have to... We'll have to, like, filter out sooner. Favorite Valorant team or player? Ooh. Historically, I've been a Sen fan, for better or for worse. This year, the players aren't really there anymore, or at least the players I was cheering for aren't really there anymore. So it's kind of rough to figure out who I'm cheering for. Like Paper X is like the obvious like fun choice, but I kind of want to see Vitality do well. And also just like based off the players, I might end up being a C9 fan this year, which does not bring me a lot of joy. That sounds very gross, but I mean, I guess what can you do? Okay, what else do we want to do with this? So we have regression test as a class. I guess, do we... Okay, so we run all of these, I guess. So I guess AST, HR, and MIR are fine. I think we should probably throw some like... We should probably throw more helpers up here. So I guess we want like... I don't know, this is getting very messy, which is inevitable, but... let's see. Okay, I guess we could just like abstract all of these out in the event that like we need anything, and then we can just like stick them in the test harness anyway. So we could just do like... I don't know, what does... I guess this is just void, so this should be fine. So we want like... I guess test AST or something like that, and we can just give it the two paths, maybe. I guess input path, string, expected path. We can just do that. Also, just occurred to me that if we're outputting in a different way, we might have to account for that. Yeah, but yeah, we'll just modularize it like this. I think this is probably fair. Okay. Okay. Let's keep going. We'll just build this as we go. Real quick here, let's get rid of that for a second so we can make this work. So we give it input path, and then AST path, I believe. This is what we want to do. Okay. And then this also like helps us debloat a little bit, I think, which is helpful. Yeah, let's do let's just steal this. Yeah, let's steal this first. So this is HIR. Do that instead of this. We can just steal that line, to be honest. This is also pretty boilerplate, but I mean, it is what it is. I think we're deep loading this as much as we can. It'll always be a little bit doomed. So this takes input, path, and then HR path. This looks like I'm adding extra bloat, but I promise it will be better in a second, actually. Okay, let's add more slush here. So we should just steal that. Oh, this needs to change. HR to string. This needs to be MIR to string. Yeah, that's good. Test MIR. We give it input, path, HR path. Okay. And now I think is where it gets complicated, because we need to figure out passes now. Yeah. And then we have like pass manager as well, and it makes like a bit of a mess. Yeah, this is not ideal, actually. We could give it a pass manager as well. I think that's how we make this work. Or I guess we could even just do it here. What type is this? It's unique putter of pass manager. I guess we could just give it a pass manager pointer. What type is this? Oh, it's just pass manager? Wait, seriously? Oh, it's middle end, I see. This should be given as a putter, so we can just yoink that. And then we can, and the reason why this all mattered is because now we can do this with LIR as well. So now we can throw this in here. Or wait, no, down here actually. I've been told that figuring out how to do or express things in assembly is the easier part of a backend. I think so, yeah, because that mostly just comes down to like how your data structures are designed. If you've if you've like written out like your memory representation of the program properly, it should be pretty like one-to-one. Like you're kind of just like expanding macros or like maybe doing a little bit of information processing. But like it is like it's difficult to write. I guess like assembly being difficult to write is distinct from it's distinct from like the backend specifically, because with the backend, like you've already had a bunch of different steps in front of it that turns the program into like pseudo assembly, I guess, or something that's more assembly like, something that's like less abstracted away. And at that point you can kind of just like, you can assume that the program like has the correct functionality, but you just need to take the logic and just like encode it, I guess. So it's less like thinking through what the assembly does and more just like how do we turn this into like, literal assembly, I guess. Yeah, it's more of an encoding question rather than like a strictly logic question at that point, in my opinion. Okay, let's call this LR initial. Okay. So now we want to give this the pass manager. that. Nice. If PM, I guess, we could run passes. Yeah, and then we can give it like null putter. Or we could just give it 0-1 even. That might be better. Actually, yeah, let's just give it 0-0, I guess. Right? Yeah, 0-0 should be like default maybe. Yeah. Let's do 0-0. I think that's how we want to structure it. What is this? We define this? Huh, okay, I guess we do, fair enough. Okay. So we want... we'll figure out what to put in this in a second. For now, let me just finish writing this, actually. This should be fine. Let's just give this the pass manager as well. And then we want to lower it to LAR. Okay, there we go. That should be good. That's all LAR initial, and then we want like test LAR. So this should be like stood. Or wait, just why am I not copying this? We can do that. Do this. Now we can yoink everything. We can just like throw liveness in here for a second. We can give it like interference. So this is compute interference. This takes... what does this take again? Oh, we need to import interference. Okay, so what does this have? So it takes LAR and then liveness, I guess. There we go. I think that should be solid. At this point, at least. Yeah, and then we can just compare, and like life is good. And I think that's all the slush we have. Okay, that looks like all of it. So we can just take this, and we can reuse these, I guess. Okay, so we give this all of this, and then we can give it like middle and initialize 0-0. Yeah, like that. I guess if this is gonna be like less expandy, we may as well just like extend this out a little bit. I don't know. Well, I think this is how we decompact it properly. Okay, so we want auto PM. Let's just yank that. Make this 0-0. And we give it PM get. There we go. Okay, and then we can just steal all of this. And the nice thing is we can just, well, kind of reuse this, I guess. So we can just throw this in here. This gets 0-1 instead. And then here we can just paste that all in there. Yeah. So this is this should probably clean things up a little bit. Build passes from file. Okay, we return null pointer. I guess that makes sense. If that's what's happening. Okay. But why not just throw the thing in there? Why am I like separating it like that? I guess like separation of concerns, but this is no less boilerplate, it feels like, at least right now. Can I just do this? Oh, wait, I can just do that. Wait, that's neat. Okay. Okay, I guess we could do a null pointer check in here, to be honest. I think that's probably the least awful way to do it. Or actually, wait, ooh. Wait, I have an idea now. So if it doesn't exist, then we can just skip. Yeah, I kind of like this. I'm liking how this is looking a little bit more. Yeah, I can do that. Intimidated by writing compilers, we're one for brainfuck, but need a lot of help. I guess that's fair. The other thing to think about is the backend is probably the most difficult part, to be honest, in my opinion. So I don't really think like, I don't know. I feel like that is also like kind of just the expected outcome, you know? So like it is what it is. Okay, let's clean this up a little bit. I think we can do like that. So that splits up like front end, middle, and back end a little bit more explicitly. Yeah, I know we're like adding a lot of white space, but it's fine. Did you try the Anthropic challenge? I've heard of it actually. I was gonna do it with one of my friends, and then we both kind of forgot and like ran out of time. It seemed interesting. Part of me wishes I did that. Part of me is happy that we didn't, because well, time. But yeah, maybe if something similar comes up again, I think I might like give it some more serious thought at least. Okay, let's do that. Let's give this a 1. Down here, we can give it null pointer as well, and then we will skip inside of there. So we can just give it this, to be honest, I feel like. Like that? Okay, neat. Okay. And then down here, we can kind of just... I guess we can just steal this. We can make this LAR. And down here, we can do LAR initial, I think. Please don't be too long. Okay, nice. Oh, okay. Here we can do a 1 again. And then here we can stick that there. Like that. There we go. Oh, new lines. Okay, whatever. And then down here, this is all just LIR. Okay, cool. So we can just like steal all this. Let's do like 13. Ah, this is a macro, I see. That wouldn't work. Let's delete that word. Still up? Oh, okay. Okay, I might give it some more thought then. We'll see what happens. There's no guarantees at all, but that could be fun. Okay, that condenses down again. Huzzah. So on average, we have not deleted lines, which is really funny. But this is a little bit easier to work with now, at least I feel like. Okay, parameterized test. That's what this is. I remember. This generates a bunch of tests. Okay, yeah, that makes sense. Okay. The other thing I was thinking about was making the test names like the literal directory. Yeah, so like making this less awful to read. I'm not really sure how. Regression test, and then we want to do like, I guess we want to like go to the output maybe. Or at least I was like thinking about maybe structuring it like that. Test if. Yeah, I don't know. This is rough. Actually, we can just delete this and then add .c maybe. That'd be pretty. Focusing on accelerators, or CPUs. I'm mostly looking to get into like CPU stuff at least. Okay, we remake the tests. Oh, that's not ideal. What happened? Call chain.c is invalid. Oh. Well, that's annoying. Okay, we need that. I guess we can't use a dot. There we go. Tests are failing. I don't know why they're failing. Again. What did I change? What? Okay. Okay, let's figure that out real quick. Let's figure out what broke. Or maybe we just go back to that. What the hell? Did I like... Where... Okay, I might have like called something wrong. If it's... Okay, let's run build bin tests, or regression tests. Let's see what the diff looks like. Oh, am I comparing against the wrong file? That might be what I'm doing actually. Yeah, that's why. Yeah, that's completely why. Okay, let's do that. Do that. Down here, this is LR initial, LR path, I guess. Wait, this is LR01 path. If you consider GPUs, a friend of mine at AMD told me the performance team are looking for people who have worked with compilers. That could be interesting. Okay, well, I guess that will come down to next recruitment cycle. Yeah, because for better or for worse, I do have an internship for this upcoming summer. So we'll see how next recruiting cycle starts looking. But yeah, I'll be sure to apply. Yeah. Perhaps I'll ask for a referral when the time comes as well. that might be very beneficial for me. Good luck, thank you. This is select. Okay, well we've recluttered a little bit, but this is fine. Yeah, this is we have made a mess. I think we've made a mess. Okay. Yeah. How can we clean this up a little bit? Can we deduplicate this somehow? Maybe the names are long. Maybe the middle and namespace stuff. Can we just like stick multiple namespaces at once? Is this a thing? I mean, I guess if this is like a test file, I think it's fine. Are you hitting a bug? No, I'm mostly just like doing cleanup work right now. Yeah, okay, we can keep that. I guess we could stick like using on here, I think. I don't think it's that bad, at least. Using what do we need here? I guess front end? Or wait, no. How do we... Or namespace, right? Is this a thing? No, this is not. I feel like I've like forgotten how to do the very basic thing that like everyone in their like intro to C++ class does. Names, use multiple namespaces at once. Using namespace. Okay, that's what we want. Yeah, okay, this makes enough sense. I think it's fine to do this in test files at least. I feel like tests are like more... They're very... It's a lot more comfortable to at least make a mess out of it, I think. Every calls to free function becomes unqualified. Oh wait, yeah, this might actually cause a problem now that I think about it. This is interesting. I see you made great progress. Not really. Depends on what you think about when you look at progress, at least. What is happening here? This is crazy. Okay. I guess we could use some aliases. I think that might make things less awful. Can we like join namespaces? Join names. Combine namespaces. What am I doing here? Can we like, is this a thing? Oh. Wait, that's really funny. Wait. You made great progress? Sure, if you say so. Okay, so I closed the tab already, which is inconvenient. Okay, let's look at this again. Figured it out. Okay, so we want... Oh, what the hell? What is happening here? What's good, Frothy? I haven't seen you in a second. Hopefully you've been doing a-okay. Right now I'm doing some gross namespace things, just so I don't, like, go insane. What's the thing? What am I looking for? It was this, okay. So we want to make, like, namespace panic here, I think. It's like that. Do we have types in the compiler? It might not happen. I'm afraid it might not happen. Okay, so we can use front end, middle end, and then back end. I think within these, our namespaces are distinct enough. So this should, hopefully this lets us make things less messy. Front end, okay. So I guess we could just do panic, like this. Okay, let's just front end, panic. We need to fix this up here real quick. Okay, let's not do that like that, actually. Let's make a macro. Actually, let's make a macro. Next occurrence, change word, panic. Next, okay. Yeah, I can't find a good LLVM shirt. If you could, like, send it to me in Discord, that might help a lot, actually. Actually, this does not clean up the namespace issue at all, actually. Okay, what if we let's just be gross. Let's just include these. Surely this is fine. Okay, that works actually. That's quite nice. Does that work? And we can do backend. Ah, okay, much cleaner. Definitely, totally 100%, no issues at all. Cleaner. This is doomed. What happens if... does this fit in formatting like this? Okay, it does not. Okay, that's fine. Okay, well this file has not changed length at all, which is very disconcerting actually, given the whole point of this was to, well, clean up things. We can get rid of one line like that, I guess. Yeah, we don't care about white space here. Yeah, I don't know. We're making a mess. It's fine. Okay. What is tester? Yeah, I'm using gtest. Okay, this looks like we shrunk it down a little bit. This is all just like a complete slush pile, so I think this is fine. Okay, let's make tests. Should not crash. Okay, it doesn't crash. That's good. Using Vim or VS Code? I'm using neither. I'm using NeoVim. Yeah, unfortunate. What is happening here? I guess this makes sense. Can you explain it? It is Vim, but you can configure it with Lua, and the plugins are also just as fun, I guess. It also has like its LSP setup is less awful if I remember correctly. Did you stop doing LeetCode entirely? For now, yes. Yeah, it's like kind of the off season, so I'm not too pressed about it in the immediate future, at least. Yeah, that's kind of my take, at least. We can do build pass manager, I guess, instead of that, and hopefully that shortens the name. Okay, it does shorten it a little bit in some instances. Okay, we've trimmed more fluff, which I guess is nice. Yeah, these names are quite long. Yeah, I know. I gave up on the dailies because like I was low-key just getting rage baited. That was not worth my time, to be honest. Here we could kind of hard code these paths outside of this, but I think this is fine. Okay, let's make tests again. Okay, cool. Git add. Clean up test runner plus make sure interference doesn't crash, I guess. Okay. Yeah, this sucks less. This definitely still sucks, but it definitely sucks less, which I will take that. Okay. So that's like one of the tasks for today done. So that's the housework, I guess. So next, I was thinking we have like this sort of stuff that we want to implement. I think for now, I want to implement one of these two. Yeah, so I think maybe we do coloring and then we start with like the visitor for that like walks the program again and just like gets all pre-colored registers. And then I guess we color them like that. Yeah, so I guess we could try that out. I'm not really sure if there's a better way to do this. Imagine a whole company randomly decides to depend on this. Please do not bring that suggestion into the world. That seems rather scary. Alternatively, what I could do is I could just do CodeGen, which is like really silly here actually. Are you using LazyVim or custom NeoVim? I'm using my personal config, which is not based off of LazyVim. It's just completely hand-rolled. It's in my dot files, which is on my GitHub, which should be in the description. What do we want to do here? I don't know. Any thoughts? I'm definitely not doing coalescing for now. This is a lot of work. People is an optimization technique? Yes, it is. I'm glad you've identified that. You should try Nix? No. I do not wish to try Nix. Yeah, I guess we could. I'm between doing like just implementing the spill function and just doing graph coloring. I think spill might be easier, but I'm not really sure. The big uncertainty I have is just like how we figure out like what the, I guess, buffer register looks like. Maybe there's like a push and a pop involved. I'm not really sure. It seems confusing to me at a glance. I guess we could do coloring. I guess we could do that. We could do this naively, or we could do it like with like pre-coloring in mind. Yeah. Okay, let's start with color actually. I think that might make more sense. I guess we can figure out pre-coloring later. I guess no, that doesn't really make sense. I forgot your repo, modifying your code to modern. How do I contribute? Read the contributing section in the README. More specifically, the part where I say that you shouldn't submit pull requests, because I will not accept pull requests. I have my reasons. If anyone else in the chat is wondering why I'm not accepting contributions, just read the README. It'll make sense. Okay, coloring. What do we even do here? I guess we could. I kind of understand why we want like distinct colors now, or just like numbers, instead of like concrete registers, because then we can like, that's where like the pre-coloring thing can be helpful. Yeah, I guess like the only constraint we have is just like, I don't know, what constraints do we have? Because a lot of stuff we kind of just generate with moves anyway. So, yeah. I guess if we're moving to, or I guess how are we folding things? Because we have like physical register to virtual register. We have, oh, it's not so simple. Yeah, this sucks. This really sucks to think about. Yeah, okay. I guess we could do this naively for now, and then we can figure out what to do from there. We could just make like an initial map of just like colors, and then we can, I guess we can just figure out what to do from there. I don't know. Graph coloring is hard. Let's look this up. Graph coloring algorithm. The goat of YouTube channels, by the way. This channel saved me hidden algos. Harold told me like the naive algorithm I could use, but I forgot. I forgot what it was. Okay, let's ask GPT before I really struggle. Graph coloring algorithm for register allocation ? And we'll do that. Let's see what it does. Okay. Okay, we can do that. Oh, I guess we could do this. That makes sense. Okay, so we can just throw everything in here, I think. We have liveness, we have interference. Okay, degree less than K. Okay. +20 codes? I don't know what you're doing. I've already said, you know, you can do whatever. Feel free to submit things. I will probably say no, but you can give it a shot. What are compilers? They are programs that translate code from one language to another. So the compiler I'm working on right now translates C code down to x86 64 assembly. Or, well, that's what I'm working on at least. What is that tool that you're using? Yeah, so there's a lot of software engineering that goes into compilers at least. Okay. Okay. I guess we could do Briggs. I think that makes sense. Like, that's the way we have it structured at least. Okay, well let's look up the actual. Let's do that. Okay, it's a Regilock graph coloring register allocation algorithm. We could not pick more bottom up graph coloring register allocation algorithm. We have run out of adjectives to use here. Degree as the spill metric. If compilers are kind of translators, then aren't there codes already made for this? Yes, 100%. But there's the main reason I'm making one right now is because, well, it's fun, and I wanna learn more about the algorithms that they use and just generally how they work. And also there are new languages that always come out, or new backends / new hardware that comes out, and that needs, I guess, compiler support as well. So there will always, for now, there will be more compilers that need to be written, and that's what I'm hoping to get a job doing at least. Yeah, there very much are compilers online that exist. Like, for instance, LLVM is, I guess the LLVM project is a big compiler, I guess, tooling, toolkit, with a lack of a better description. Oh, they say it as well. If you heard of Clang, that is built on LLVM, for instance. Or the compiler that Rust uses as well. Okay, this is rough. Okay, I was reading about this degree less than R rule. The Rust compiler is called Rusty, I believe. Thanks for explaining it so easily and not in French. Yeah, I guess I don't really have a choice because I guess I need to be able to explain things to my parents. So yeah, they might need, or they might give me a lot of practice at least. Okay, graph which contains node R, or node N with degree less than R. It is R colorable if and only if the graph without the node is R colorable. Less than R. Oh, that makes sense, yeah. Because if the degree, so degree is number of edges, in case you are not very graph aware. So if the degree is less than R, the worst case scenario is each neighbor is a different color, in which case the node would be colored the rth color. Okay. Yeah, okay, that makes sense. So while the graph cannot be R colored, okay, this is Chaitin's algorithm. Who would need to use these compilers? Someone coding he'd code on C++, but after a while he thinks I want it in Java. Well, that's the funny thing. So if you're writing C++ code, your computer cannot understand C++. So you need it to turn the C++ into assembly in some way. So at that point, you would need a compiler to translate between the two. And if you switch to Java, it kind of understands some sort of non-machine code. It has its own like virtual machine sort of. But that takes, I think it's called like Java. I think like Java has a proprietary format. I forget what it's called because I haven't looked at Java in a while, but you need a compiler to translate from Java to that. So yeah, it turns out you need compilers in a lot of different places. JVM, yeah, that makes sense. Anything you recommend someone learn before jumping into compilers? I think you need to at least like be comfortable with programming languages, or at least like basic programming languages theory. I think like crafting interpreters is like probably sufficient for that. And then aside from that, I think like just like any semblance of an assembly course, I think will be fine. From there, you can kind of just like follow a book, but it's mostly just like understanding from like one end to the other, at least. You need to like have the two ends anchored, and then I think from there it's fine. Also being comfortable with like graphs, I think are really important. What kinds of companies hire for compiler roles? Big tech, quant, some like hardware startups. Those are like the big three, at least, that I've been looking at. Yeah. Okay, let me read through this again. So while we have degrees, we are or nodes with degrees less than R. We can remove it. And edges. Oh. And okay, and then we can push N on the stack. If the entire graph has been removed, then it's colorable. Okay, and then we do a while loop here. Otherwise here, okay, then we can't color. So I guess we've just kind of made a mess with this, huh? Yeah, okay. I guess this is the part that we care about, and then I guess this is the part we care about. Everything else we do later, but this is what we do for now. Okay, we can give this a try, I guess. What does this send me to? Oh, it's UW. How about that? Okay. Why does Breeze Windows? Valorant. There's no other reason. Okay. I guess we could give this a try now. I've read up on this a little bit too long. Not a fan of the bytecode VM portion. Yeah, that's pretty fair. I guess like if you want to like, I think it's like a solid like. I guess the term is like introduction. I don't think like it definitely makes a mess here and there, but I think at least conceptually it does the legwork for that. Yeah, that's my take at least. Okay, what am I doing here? So the degree. I guess we could. Oh yeah, wait. This is easy actually. This makes sense. Yeah. Okay. So if we look at, I guess, interference. This is our graph. So the type here. This is an unordered map from register to register set. So we can just like look up registers at least. Okay, so we want, I guess, while, I guess this will eat up interference, which is fine, but yeah. So we want while interference, or while it's not empty, we want to keep iterating. So I guess right now we're like eating nodes. Nodes with in degree less than n, I guess. Or is n the variable to use? R. Okay, so I guess we'll leave that to do there because I'm lazy. Let's just int. You're from South Korea? So bad news. Bad news. I am in fact not Korean. Yeah. Feel free to keep guessing, but yeah, I'm not South Korean. Or even Korean. Yes, num reges. We can do we could just hardcode this, right? So we have, how many registers do we have? You look like one? That, I mean, if you say so. That's a crazy line though. That's a crazy sentence. I guess you might have watched a little bit too much Squid Game, if I had to guess. Specifically season 2 of Squid Game. Okay. So how many registers do we have? I guess we could look in LIR. I think that's where we've determined this. 6, 9, 12, 15, 16. Yeah, we'll just do that. Okay. Okay. We can just loop through interference until we find something that we can pop, I guess. And then we can just keep going through interference. I think that's like the least awful way, because the big problem we run into is if we remove something, then we have, or if we like remove an element from interference, then the problem is we invalidate the iterator because it's a hash set or hash map, or both the hash map. There is a hash set that we don't care about invalidating an iterator for. We do care about the hash map though, that everything is stored in. Okay, so we want, So we got auto, I guess reg, and then edges, I guess. We can do that for now. For that in interference, we can do something. How's luck been with applying to internships? I have an internship for this upcoming summer. It is in fact compiler related as well. But I am keeping the series going because it is not full-time. that's the big reason. It's not a local trading firm. I will basically be given 3 months just to play around with their compiler toolchain and see what I can do with it. Yeah, it should be a good time. What kind of IR are you making? It's mostly, or at least like, it's mostly 3 address, or, I don't know, I'm not really sure, like, concretely. I am also not really familiar with, like, very technical, I'm not very familiar with, like, technically speaking, like, what types of IRs exist. So I don't think I can really give a good answer to that, unfortunately. Is this a personal project? Yes. I have like a lighter coursework load this quarter, so that leaves me a little bit more time for this. But even last quarter, just like setting aside like an hour or two every day, it has built up to where we are now. Okay, so virtual reg. So this is, oh, I don't want to dynamic cast every time. That's really annoying. Okay, let's make a temporary colors thing as well before I forget. So map from, or I guess we want to make the stack, I guess. Vector, I guess. Vector of LR virtual register. Maybe I should just do a pass to filter out the physical registers, huh? Or maybe I just keep them in. I don't know. That might be smart. I have to make a CSS preprocessor for my end of uni project. What language do you recommend? Whew. I think a language with strong pattern matching is what you want. And that's just like, it depends on like what you know. Like Python's probably fine. I think like OCaml's probably comfortable if you know it. Just like something that you don't have to like write a giant if else if tree with, because if else if else if else if else if else if is like really annoying. But yeah, I think just like as long as you have like a good way to handle like parsing, I think you will be fine regardless. I also imagine like as long as like if you're given like parser generators, then like by all means just like use whatever. Like at that point I don't really think it matters. But as long as you have a way to avoid just like making a gross like if tree, I think you will be fine. So this should be colorable, I guess? We could do that. Do it in C++. That is insane. that might actually not be worth it. Okay. Let's look at the in degree of these. Do you know Rust? Yes. Do you know how to make parallel compile? I've like thought about it. I haven't really like figured out what would be parallelizable. But I guess like that could be something to like think about. Before you ask, you can try to implement it. I will not accept it, or I will not approve a pull request. because I would like to implement things myself. The parsing thing, yeah, it's just like, let me give you an example actually. Do I have this project in here? Yes, okay. Okay, this, let me just make a new window for this. Kaleidoscope. Okay, so all of this is like ancient stuff, but so LLVM, I've like mentioned this before, LLVM is like the big like compiler, I guess, framework that people use. They have a tutorial for like a proprietary language. It's called Kaleidoscope. I followed this at one point, but part of this we had to like write a parser. So if you look at the parser here, you will notice it's very messy. This switch block is fine, but then like you go down a little bit, you have like if else's in there, and it's like yuck. There's like a really bad example somewhere, I think. There should be a good one. I'm fairly sure there was like a really ugly thing. Maybe it was in the Lexer. Ah, yeah. Yeah, okay. So something like this is what you want to avoid. Because the whole if tree thing just like, it looks awful and it's just like kind of messy. Whereas if you looked over in the parser here, I know this is like C++, so it kind of like defeats the purpose a little bit. But here, like we have like a switch block and it matches like this enum type, which, or I guess it's just an int, but we can match that value and then we can like do different things based off of that. Right, so this feels a little bit more maintainable than the code on the left. So what you want is a language that is able to, I guess, provide this sort of granularity, and like have the proper syntax to do this sort of pattern matching. So you don't have to do like this ugly if tree thing. Hopefully that makes sense. Let me know if like I should explain it in a different way. How about using Rust? Yeah, I thought about using Rust. If I were to go back in time, I'd probably rewrite everything in Rust. I'm mostly using C++ because, well, I need more C++ practice. There's not much else of a reason to it. Yeah. Yeah, I guess Lane, I think that makes sense. I guess the only reason I'm using a parser generator is because, well, I do not care about parsing. But I think that's like pretty reasonable, at least. Yeah, C++ is a never-ending endeavor. Okay. So we have register. So if edges size, if this is greater than equals colorable, then we continue. So we skip it. What the hell? This is set, so we have size. What is, oh, not colorable, num regis. Okay. So if all of its neighbors are a different register, I guess we can't really do anything about it. So we continue. Okay. And then, what type is interference again? Oh, that's just a map. Wait, is this per function or is this general, actually? Oh, wait, this is really annoying, actually. Wait, I might have messed up somewhere. Okay, there's a chance that I've messed up somewhere. Uh-oh. I kind of get, but which one should I use? If you wanted to just if you want me to just make a decision for you, I think OCaml is pretty comfortable if you're comfortable with learning new languages. If you want the path of least resistance, I think Python will be more than good enough though. Yeah, crazy how I'm recommending OCaml. I didn't expect this to ever happen in a stream. But here we are. Yeah, let me react to something. Okay. Yeah, of course. Let me know if you have any other questions. Okay, what am I doing here? Oh, I was checking interference real quick. Yeah, so we go for program. This is very annoying. This is for one program, so that should be fine, at least. Maybe we should make this a vector as well. What's good, MD? Good to see you. This is very annoying. Do we do interference per function or for the whole program? Do you have a plan of making your compiler self-hosted? No. What? I don't. This is not a web app. What? It feels like it would be a little ridiculous to do that. Although actually, now that you mention it, that would go well in a portfolio, huh? Interference graph for register allocation. Do I need to make one per function or just one for the whole program? Ah, okay, that's really annoying. Okay, we need to redesign that. We make good friends with a Midwestern C++ programmer that has Asian ancestry. I don't know what that means. I'm not sure if I'm supposed to be offended, but cool. I mean, rewriting your compiler in your own language. I mean, that's not the goal of this compiler, but I guess that could be fun. I don't know. I don't particularly care. Okay. Let me lock in for a second. Yeah, let's start off with this for now. We will just work off the assumption that this is just fine, and then we will refactor probably next time. For now, I just want to get this working at least. Or at least running, and then we can worry about correctness later. Okay, so if it has less than numReg's degrees, Dark, I can't lie, I do not think I can. I do not think I will do that. I genuinely feel like I'm just getting trolled right now. I might be falling for rage bait. This might not be bait. I do not know anymore. I feel like I'm falling for rage bait right now though. Okay, so now if this So this register has less than numReg's edges, which means it is colorable. So we can insert it. So push back reg. I guess we want a dynamic cast actually. So we want dynamic cast to that type. We give it reg, then if virtual reg, then, whereas if not, then we can continue. Otherwise, we push back virtual reg, and then we need to erase its edges. Wish me luck next Monday. I get the letter. It tells me if I got into the IT program. Ooh, that's a fun time. Good luck on that. Let me know how it goes when the time comes. Dynamic cast is haram. Yeah. Unfortunately, I feel like compilers tend to use it a lot, unfortunately. Okay, so we can push this back. We want to remove all the edges, and then we can just remove it. Okay, so then for neighbor in edges, I guess. Hey. So then colorable at neighbor, or I guess colorable at, what type is this? What is wrong? Oh, we can figure this out in a second. Okay, that's a register star. Okay. So, this is so annoying. We're gonna need to, okay, here's what we're gonna do. We're just gonna make this register. Maybe we should make like a is physical register thing in our operand. I think that might be the solution that I'm missing. So we have that. We also want like, I guess we could put this at the bottom maybe, because that's like least like straight up getter. So we want bool is physical or is virtual register. Or actually no, wait, we can just get regnum, right? Wait. What is the regnum for, what's it called? Let's keep that as is. Let's look at constraint register again. So when we get regnum, it should call the super, which should, I think, just be register or virtual register. But it does have the extra constraint field. So I think that is the physical register, but we can just get the regnum actually. Okay, so that actually makes things a little bit easier. So instead of doing this, we can do reg, get regnum. So if that is not equal to, so register num, we want virtual. So if it's not a virtual register, we skip it, and that avoids the dynamic cast. Yeah, okay. Alright, MD, I can't lie, you are I'm gonna need you to chill a little bit. I can't lie. Okay, let's do this. So you can insert the register if it's not a virtual or if it is a virtual register. So for each neighbor, I mean, if you want me to ban you, then like, sure, I guess. But like, at least just like, maybe don't say things that make me feel uncomfortable. Like, that would be very ideal. Yeah, I would very much not like to be violated. That would not be very ideal. Yeah, okay. So for each neighbor, so colorable at neighbor, or not colorable, we want interference. Neighbor. What is this type again? This gives us a set of register. So we want to... Did I spell this wrong? Am I tripping? I guess not. Are you kidding me? Okay, I guess. Edges, I guess? What is wrong here? Oh, that's why that looked wrong. There's H. Yeah. Thank you, Physics Baller. Compiler rules exist? Yes. A lot of big tech, a lot of quant, a lot of like hardware startups. Those are the big areas. Okay, we could keep this actually. Okay, so we don't need this anymore, I guess. So we want to erase reg, I guess. Yeah, we can do that, I think. We just do this for all of these, and then life is good. Wait, am I even looking at the right thing at least? So what do the edges represent here? Yeah, I'm not. I might be understanding the algorithm wrong. Is this NeoVim? Yes. I've been using NeoVim on WSL as my like dev environment at least. Okay, let's open up Advanced Compiler Design. Okay. Okay. Let's. I know there was a. I know the algorithm existed here somewhere. I do not remember where, but it was somewhere here. Western's really slow on Windows. It's felt fine to me at least. It's definitely not as like snappy as, or at least like Western itself feels pretty snappy. I honestly think it's more like Windows and WSL that's slow, if anything. Okay, here we are. So this is the rule. Okay, so if there are, I see. Okay. So it is adjacency lists. N-ints. What is N-ints? This was defined somewhere. Oh, number of interferences. Okay, yeah, then this is fine. This feels fine then, actually. Does this make sense though? Mushroom Spoke is heavy on backend, doesn't really go over lexing, parsing, etc. Yes, 100%. If you look at the chapters, like we bring up symbol table, and then from there it is completely middle and then backend. So I think it might just not go over lexing and parsing at all. But like that's fine. They're like those are like kind of I don't know. I've never really understood people's fascination. Sorry. I've never really understood like people's fascination with like lexing and parsing specifically. It's like it seemed to be pretty solved, at least to my understanding. Maybe there's like something I missed, but it just seemed like generally uninteresting, I guess, problem wise. Okay, let's just blindly let's blindly just do this, I guess. Okay, so we push this back, we erase all the neighbors, and now we can erase reg, I think. What does this take? Does this take key? Yeah, okay. So we can just erase reg here. Yeah, so now we've removed the node roughly. At least looking at like this pseudocode. Okay, I guess that makes sense. And then here we break, I guess? Yeah, because the iterator is nuked, so we don't want to break. Okay, and then we do that if it... No, this condition is wrong because we will infinite actually. I don't know. Let's just avoid the infinite. I don't know. I'm kind of exhausted, so I think it might be time for me to call the stream here. Let's commit some stuff. Here we start at what's it called? What's the degree less than R for coloring? Okay. Yeah, let's push this. Life is good. Okay. Thank you all so much for showing up today. I'm quite tired. Good luck. Thank you, Danny. I appreciate it. Yeah, if y'all haven't already, make sure you like the stream, sub to the channel. You know the usual. Discord in the description. Join that if you want to get pinged when I go live or chat with everyone else in the community. LinkedIn down there, GitHub down there, GitHub sponsors down there. Yeah, take care, y'all. Take it easy. And I will hopefully see y'all tomorrow if nothing goes wrong. Have a wonderful rest of your day, y'all, wherever you are.